Since 2019, Betelgeuse, the massive red supergiant star in the constellation Orion, has exhibited peculiar behavior, sparking curiosity and excitement among astronomers and stargazers alike. Known for its fiery glow and vast size, over 1,000 times larger than our Sun, Betelgeuse has been showing signs of significant changes, suggesting it might be nearing the end of its stellar life. In 2019, the star underwent a dramatic event now known as the Great Dimming, during which its brightness mysteriously decreased. This anomaly raised global speculation about whether Betelgeuse was on the brink of a supernova, an extraordinary cosmic explosion that marks the death of a massive star. However, in 2023, Betelgeuse surprised astronomers once more, not by dimming but by brightening dramatically, with its luminosity increasing by nearly 50% in a matter of days. This unpredictable behavior has reignited questions. Is Betelgeuse truly nearing its explosive finale, or are these fluctuations simply part of its natural cycle? The Great Dimming and its aftermath. The unusual dimming observed in 2019 and early 2020 drew significant attention. By February 2020, Betelgeuse's brightness had dropped to an all-time low. Scientists determined that this wasn't due to internal processes but rather a massive ejection of hot gas from the star's surface. This gas cooled and condensed into a thick layer of dust, temporarily obscuring Betelgeuse's light. Although the dimming eventually subsided, the event disrupted the star's usual brightness patterns. Betelgeuse's typical 400-day cycle of variability was shortened to around 200 days, resulting in the 2023 surge in brightness. Experts believe this increase was an aftereffect of the dust cloud dispersing rather than an indicator of an imminent supernova, a supernova in our lifetime. While Betelgeuse is nearing the end of its life, the timeline for its demise remains uncertain. Most astronomers agree that the recent anomalies do not necessarily signal an impending explosion. Instead, they are likely normal variations in the life of a dying supergiant star. Betelgeuse, estimated to be around 10 million years old, has already outlived its shorter life expectancy compared to smaller stars like our Sun, which shine steadily for billions of years. When Betelgeuse does explode, it will briefly outshine the entire galaxy, becoming visible even during the daytime from Earth. However, this event could occur tomorrow, or it might not happen for another 100,000 years. The science of star death and cosmic recycling. The death of a massive star like Betelgeuse is not the end but the beginning of new cosmic cycles. During its lifetime, Betelgeuse has fused lighter elements like hydrogen into heavier ones such as helium, carbon, and oxygen. These processes release immense energy, making the star shine brightly. When the star eventually runs out of fuel, it will collapse under its gravity, triggering a supernova explosion. This event will scatter vast amounts of gas and heavy elements into space, contributing to the formation of new stars, planets, and even life. In fact, the very elements that make up our planet and our bodies were forged in the hearts of ancient dying stars. After its supernova, Betelgeuse might leave behind a neutron star or possibly a black hole. While the star itself will no longer be visible, its legacy will live on as its remnants are recycled across the cosmos. Betelgeuse, a cosmic landmark. Betelgeuse holds a special place in the night sky as a key part of Orion, one of the most recognizable constellations. For millennia, it has captivated humanity with its fiery presence, serving as a celestial marker and a source of wonder. When Betelgeuse eventually completes its stellar journey, its absence will leave a void in the constellation. Yet, its contributions to the universe will continue in the form of new stars, planets, and perhaps even life elsewhere. For now, the mysterious fluctuations in Betelgeuse's brightness remind us of the dynamic and ever-changing nature of the cosmos. Whether it's a prelude to a supernova or simply the quirks of a dying star, Betelgeuse's story is a testament to the beauty and power of the universe. A while ago, Johannes Kepler recorded in his journal a remarkable event: the appearance of a star so radiant that it nearly rivaled the moon in brightness. Throughout history, humans have occasionally witnessed supernovae within our galactic neighborhood. However, no records exist of a Betelgeuse supernova. When it occurs, Betelgeuse's explosive end won't just be a stunning celestial event. It will mark an unprecedented milestone in the history of science. Never before have we been so close to observing such a monumental supernova event. Long anticipated for centuries, the impending explosion of Betelgeuse holds immense scientific significance and astronomical wonder. As one of the largest stars known, Betelgeuse's fate is intricately tied to its evolutionary stage as a red supergiant. Located approximately 650 light-years away in the Orion constellation, this cosmic giant has captivated astronomers and stargazers alike with its mysterious behavior in recent years. Since the remarkable dimming episodes began in 2019, followed by additional anomalies in 2023, speculation about Betelgeuse's imminent supernova has been intense. The dimming, particularly the dramatic Great Dimming, initially baffled scientists, leading to widespread debates. More recently, a sudden increase in its brightness has further fueled scientific curiosity. Although this recent brilliance is not currently indicative of an immediate supernova, it underscores the ongoing mystery surrounding the star's life cycle. Betelgeuse has exhausted its hydrogen fuel and is now in a phase where helium fusion dominates, giving rise to the creation of heavier elements like carbon and oxygen. While this nuclear fusion sustains the star's brightness and stability temporarily, it is far less efficient than hydrogen fusion. Betelgeuse's internal dynamics are driven by intense gravitational forces compressing its core, triggering nuclear reactions and releasing energy. Eventually, this process culminates in a catastrophic collapse, leading to a supernova explosion visible across vast distances. Supernovae are cosmic phenomena characterized by their extreme luminosity and brief but intense brilliance. These events play a crucial role in the evolution of the universe by dispersing heavy elements into interstellar space, elements essential for planet formation and life itself. This enrichment contributes to the cycle of cosmic birth, death, and rebirth. The study of supernovae provides invaluable insights into key astrophysical processes, including nucleosynthesis, stellar evolution, and the formation of stellar remnants like neutron stars and black holes. Witnessing a supernova up close, particularly one as near as Betelgeuse, offers an extraordinary opportunity to observe these processes in real time. Such an event would not only validate theoretical models but also significantly expand our understanding of stellar evolution and the physical laws that govern the universe. Advances in telescopes and observational technologies developed over the decades have enabled astronomers to monitor Betelgeuse with unprecedented precision, preparing us for its eventual explosion. When Betelgeuse goes supernova, its brilliance could rival the full moon, potentially even being visible during daylight. This unparalleled display will make it a once-in-a-lifetime celestial event, providing crucial data for astronomers studying the universe's vastness and complexity. Beyond its scientific importance, Betelgeuse's place in human culture and history adds another layer of fascination. As a prominent star in the constellation Orion, it has served as a navigational beacon for astronomers and a cultural symbol across civilizations. Its eventual supernova will mark the end of an era in observational astronomy while opening new avenues for research and discovery. The global astronomical community remains vigilant, closely monitoring Betelgeuse for further developments. Recent observations have revealed fluctuations in its brightness and spectral characteristics, prompting ongoing investigations to identify any signs of imminent change. Each observation deepens our understanding of stellar dynamics and the inherent variability of massive stars nearing the end of their lives. Technological advancements in both space-based telescopes and ground-based observatories continue to enhance our ability to study Betelgeuse and other cosmic phenomena with exceptional detail. These tools enable astronomers to capture high-resolution images, analyze spectroscopic data, and detect subtle changes in brightness and composition over time. In addition to scientific intrigue, the public's fascination with events like Betelgeuse's supernova reflects a broader curiosity about the universe and humanity's place within it. The anticipation of witnessing such a rare and spectacular event captivates minds worldwide, highlighting the universal appeal of astronomy as a gateway to understanding the cosmos. The data collected during and after Betelgeuse's explosion will provide a wealth of information about the mechanisms driving stellar explosions, the formation of neutron stars and black holes, and the distribution of life-essential elements throughout the universe. This singular event will not only be a dazzling spectacle but also a profound contribution to our understanding of the universe's and a central figure in myths and legends for millennia. When it eventually meets its end, it will alter the appearance of the Orion constellation forever. Though some view this event as having potential cultural significance, most believe that life on Earth will continue unaffected, even after Betelgeuse's explosive finale. For scientists, the ongoing dramatic changes in Betelgeuse are an extraordinary opportunity. Observing the final stages of such a massive star within our own galaxy, only 650 light-years away, provides insights that are both rare and valuable. Advances in technology have enabled researchers to study supernovae in distant galaxies, but witnessing this event up close in the Milky Way makes Betelgeuse's story particularly compelling. Betelgeuse is approaching the end of its life, and its dramatic finale will be visible to the naked eye. When it explodes, it will shine brilliantly in the night sky, offering an unparalleled cosmic spectacle. Currently, Betelgeuse has exhausted its hydrogen fuel and is fusing helium into heavier elements such as carbon and oxygen. Over millennia, these fusion processes have produced vast amounts of energy, keeping the star stable. However, as the fusion of heavier elements becomes less efficient, the core will eventually collapse under gravitational forces. This collapse will compress the core's matter to such an extent that electrons are forced into atomic nuclei, creating a sudden surge in pressure and temperature. The core's destruction will result in a massive explosion, a supernova. This explosion will release enormous amounts of energy, propelling the star's outer layers into space at tremendous speeds. These ejected layers, rich in heavy elements formed through fusion, will contribute to the formation of new stars and planets. When Betelgeuse goes supernova, it will shine so brightly that it will be visible in daylight for a few moments. For weeks afterward, its remnants will illuminate the night sky, possibly rivaling the brightness of the full moon. Astronomers predict that Betelgeuse's brightness will increase noticeably in the days leading up to the explosion, signaling the event's imminent occurrence. The exact timing of this cosmic event remains uncertain. It could happen tomorrow or not for another 100,000 years. Past supernovae, such as the famous SN 1987A observed in the Large Magellanic Cloud in 1987, have provided valuable insights into these phenomena. Even further back, Kepler's supernova in 1604, recorded by the renowned astronomer Johannes Kepler, offered a rare glimpse into the birth of a new celestial body. If you regularly gaze at Orion and notice Betelgeuse shining unusually bright, it could mean its final act is near. For now, we can only wait and marvel at the possibility of witnessing one of the universe's most spectacular displays.